Solving systems with inverse matrices. So we're going to practice using those inverse matrices that we found to solve a system. So a little reminder that if you multiply an inverse matrix by itself, you get that identity matrix. Remember that identity matrix is all the ones are in the diagonals and there's zeros all around it, and it's however large it needs to be, a 2 by 2, a 3 by 3, or 4 by 4, or so on. So when you're solving a system, we're going to have some matrix here. This is actually going to be the coefficient matrix, and I'll show you what that is in a little bit. This is going to be our variables, like our x's and y's, and this one is going to be our answers. So if I wanted to get just my variables by itself, which is how we solve a system of equations, we have things like x equals 5 and y equals 4. What we're going to do with the matrix is we're going to find the inverse of our first coefficient matrix. Because if you, again, as I said up here in the reminder, if you multiply an inverse by its matrix, you get the identity matrix, which is the matrix version of 1. So you just essentially get your variables by itself. Now, multiplying matrices, order actually does matter. So you need to put your identity matrix first, not last. So you do need to put your matrix first. So this matrix is first here because that's the only way you can multiply it. You can't put it in between those two right there. So you're gonna put your matrix, your inverse matrix first, and then you're gonna multiply it by your answer matrix. So we're gonna do some inverse matrix and then some multiplication. So I'm gonna show you what that means and what that looks like. So here's the steps of what you're going to do. First, you're going to write the system as matrices, and I'll show you how that works. Then you're going to find the inverse of the coefficient matrix. Ooh, I don't know where that went to. The inverse of the coefficient matrix. So we've done inverse matrices. So we're going to use that skill and we're going to find inverse matrices. Then we're going to multiply the inverse matrix of the coefficient matrix by the answer matrix. So we're going to use our multiplying matrices skill next. So let me show you exactly what that means. So here is our system of equations. X plus 2y equals 4 and 3x minus 5y equals 1. I've purposefully chosen matrices or systems that have whole number nice answers. What's nice about using a matrix is if your answers are really horrible looking fractions, it's almost easier to use a matrix than it is solving a system. But for our practices, we're going to have nice, pretty whole numbers. So the coefficient matrix, what that means is you're going to take the coefficient of the x's and y's, and you're going to make a matrix out of them. So the first equation has a coefficient of 1 and 2. The second equation has a matrix of 3 and -5. So I'm just collecting the numbers in front of x and y and making them my coefficient matrix. My variable matrix is x and y because those are my two matrices, two variables that I have in my original equation. And my answer matrix is a 4 and a 1 because my answers are a 4 and a 1. So if you happen to multiply those matrices together, by the way, you get your original problem back because you'd go 1 times x is x and 2 times y is a 2y. That gets you back your first equation. And then if you multiplied 3 by x, you'd get 3x, and -5 times y, and you'd get -5y. So multiplying those two matrices together does get you back your original equation. Now, what we need to do is find the inverse of this matrix. So we need to find its inverse. Okay, so what do? First, we need to find the determinant. So 1 times -5 is -5, and 3 times 2 is 6, but that's our negative because that is the negative direction of our diagonal. So our determinant is a -11. So I'm going to have 1 over -11 as my determinant. So then for my inverse, I'm going to switch these two. So I'm going to put the -5 up here and the 1 down there. And then I'm going to find the opposite of the other two, but I'm going to leave them where they are. So hopefully this kind of sounds familiar. So if I wanted to find my inverse matrix, I'm going to basically divide everything there by -11. So I'm going to just write them as fractions. So a negative divided by a negative is a positive, so that's 5/11. -3 divided by -11 is 3/11. -2 divided by -11 is 2/11. And 1 divided by -11 is -11. So here's my inverse matrix. I am now going to multiply it by my answer matrix, which is 4, 1. Because if I multiplied these by my inverse matrix, my a to the -1, this is now my identity matrix. If you multiply a matrix by its inverse, it's at the identity matrix, that 1. So I'm going to multiply my inverse by my answer matrix. Okay, so to do this one right here, I'm going to do 5/11 times 4/1, essentially, which is 20/11. And I'm going to add to that 2/11 times 1, times 1, which is essentially just 2/1, so just 2/11. And that gets you 22/11, which is 2. So there's 2. I just got a nice answer. You're definitely going to want to do scratch work for this stuff. Okay, so have a nice piece of scratch paper or work on the desk. Now to find my next one, I'm going to go 3/11 times 4, which is 12, 12/11. And then I'm going to do 1 times 1/11, which is -1/11. So 12 minus 1 is 11/11, which is 1. So this is my answer matrix. I now know that x equals 2 and y equals 1. Why is it x equals 2 and y equals 1? Well, if you look at my variable matrix, x is on top and y is on the bottom. So x equals 2 and y equals 1. Let's try that one more time. So here is our system of equations. I'm going to write it as matrices. So we have 5 and 1 because it's 5x and 1y. 3 and 2 because it's 3x and 2y. There's my variable matrix, and it's going to equal my answer matrix. So now I need to do work for my inverse. So my determinant, 5 times 2 is 10. 3 times 1 is 3, but that's in the negative direction, which means my determinant is a 7. So I'm going to multiply my inverse matrix by 1/7. So let's figure out what my inverse matrix is. My 2 and 5 are going to switch places. My 3 and 1 are just going to become negative, and they're going to stay where they are. So if I multiplied all of those by 1/7, that's just the same as dividing it by 7. So I'm going to have 2/7, -3/7, -1/7, and 5/7. And I'm going to multiply that by my answer matrix. 13 and 5. So let's find our first answer. So I'm going to multiply 2/7 times 13. So 13/1. 2 times 13 is 26/7. And then I'm going to multiply -1/7 times 5, or 5/1, which is -5/7. If I subtract 26/7 minus 5/7, I get 21/7. But that is just a 3. So this is a 3. And then I'm going to multiply that row by my answer matrix. So here's my work for this one. I'm going to go -3/7 times 13/1, which is -39/7. Then I'm going to multiply 5/7 times 5/1, which is 25/7. And my answer is in terms of sevenths, common denominators. 39 minus 25 is 14 on the negative side, which is the same as -2. Which means that my answers are x equals 3 and y equals -2. So we will be practicing this in class. I'm only going to have you do a couple problems for your assignment, but I want you to be able to use an inverse matrix.